Hi and welcome back to Eric's Bench. Today I guess I have really an interesting repair here for you. So this here is the very famous standard C620 twin band radio. So this is the 70 centimeter and 23 centimeter radio. And well, if you have one of these radios and if it works, you never will let it down, because this is really a quality radio. And there are really many of these radios still in the market, but some do not really work, and that is what we want to talk about today, because you know, these radios, as I said, are really high quality, and these radios only needs maintenance, and with some maintenance this radio will work as it is new. And you know, it is really worth to maintain these nice radios, because today you never will get radios of this quality. So let's see what the problem is, let's see how we can solve it, and maybe you can do your maintenance on your radio for your own. Okay, and here it is, a real legend for several decades. Many radio operators are still using this radio as portable solution. I mean, yeah, here we have missing our battery pack, but that is not the problem of today. We really want to look into this radio, and we want to talk about the most common problems we have with these radios. But this is really easy to handle. I mean, this radio suffers from some of the well-known problems. So for instance, here our keypad doesn't work any longer, so that is a common problem. Then the audio, the receive audio, is very low, and that is also known because the used electrolytic capacitor used in here are worn out, and so we have to swap them out, and we have to put new in. And then another problem is that here the knobs are getting very sticky, and that is something we can solve as well. And so let us work step by step through, and you will see what you really can do to maintain this radio. And if you know this radio, and if you have worked with these radios, you know that it is really a nice piece of high quality. And I think you really will agree that it is worth to get this radio back working. So first of all, let's try a little bit, because I do not have the battery pack. We will directly connect it to our power supply, but other than that, we really can test out more or less everything, and then we can start afterwards our maintenance. Shall we? Okay, so I've connected it to my power supply, and yeah, let's switch it on. Yeah, and you see it fires up, but even if I increase or crank here our volume up to maximum, so you do not hear a sound. I mean, we see our channel knob is working, but as I said, and that is obviously true, we have no keypad activity, so it does not work at all, and I can't switch here between main and sub, and squelch off doesn't work, light doesn't work. I have here only my receive LED, which is working, and well, it seems that the transmitter is working somehow. That needs to get investigated a little bit more, but other than that, you see, I'm not able to to do anything here on the radio. Well, what I'm really interested in is I just connect my generator here to the radio, because I just want to see if it receives or not. Okay, so I've connected it to my generator, and if I switch my generator on, you see that here our S meter is coming up, so that means it seems that the radio is somehow receiving, but there is no tone. Don't know if there is a problem with maybe our internal speaker or so. Let's see if I maybe can connect it here to an external speaker. Does that bring any change? Let's see. No, so external speaker is connected, so and that is for 430. No, nothing. So yeah, definitely that means this radio really has all the known problems, as we have for instance squelch doesn't work, or AF is weak or completely vanished, what we have here. Then we have some radios which permanently transmitting, or we have display flickering, and well, this all is known, and most of the problems, as I already said in the intro, are due to worn out electrolytic capacitors. So let's take the radio apart and let's have a look inside, and then we can go ahead. Okay, so what we need is a Phillips screwdriver, and when we flip it over, so we see two screws. We have one there and another one there, and then we have here our button screws, and we only need to open this little screws, and therefore you need really a small Phillips screwdriver just to be able to open it. But definitely no special tools, so we only need to open this both here. Again, I'm working around my camera, which is always no fun. But anyways, we get it managed. Okay, so 1, 2, and then we have to take out this both screws here. and yeah, this one, and then yeah, you see I can get it off here, and now that's all what we really need to do. And now we should be already able to take it apart. So let's see. And yes, it is already open, and here it is. Here we have our radio open, so you see you can easily do it this way, and you directly have access here to our radio. 4 screws, nothing else. Just be careful, because we have here this flat wire, which is a little bit sensitive, so be careful when you flat it over here. And what we can see here, don't know, let's go a little bit closer. You see a spider was in. So that is very nice. Of course, we all clean this for sure. I just want to point your attention here to our flat cable, that we really do not damage it. Okay, so here on the left we have our microprocessor, which is down here. No, it is not that one. So this is our tone board. It is the CTCSS unit, and the microprocessor is underneath. So this is only sticked on here onto our microprocessor. Anyways, the left side is our micro processor and our audio board. And on the right side, so this is here our right side, so how we have it here on the bench. So that is the front panel, or the user panel, with here our integrated speaker. So that are the both sections. Well, one very important information which I have almost forgotten. Please do it under ESD protection, because otherwise you really can damage if you start touching the board. So just do it under ESD protection, that you do not destroy your microprocessor, or what have we here on the board. So the first, I lift up here our little CTCSS unit, and as I said, it is only sticked here with tape to the microprocessor, and we have a lot of radios where this unit is not available in the radio. So let us take this off, and you see I can pull it out, but do it gently. Don't do it with too much force, because otherwise you can damage it. And now we really have here full access to our processor board, or audio board, or however you want to call it. I believe Standard is calling it AF unit. And first of all, what we really can see are all the capacitors which are important to swap out. And yeah, so you really see here all these little SMD electrolytic capacitors here on the board, and we have here three through-hole capacitors, and here one through-hole capacitor, and this capacitor all have to go. So that is why this radio has all these faults. So if we swap out all these capacitors, then we definitely have a very good chance that the radio will work afterwards. What we should swap as well, because it is worn out as well, are these micro switches here. So we have here two, this and that, and here the down one. So this one here is our PTT, and this is our function button, the upper one, and these contacts are worn out over the years, so it is always a good idea to swap these switches out. Okay, so now we can go ahead with the knobs, because anyways we have to take them off, because as I said, this here are very sticky, and we really want to clean them, so we have to take them anyways off. And yeah, again, this is a little bit tricky, and this one don't want to get off. Yeah, I need to take the camera out of the way, so yeah, that's a little bit difficult. Okay, so my knobs are off, and now we have exactly 4 screws to get here our board off, and we have one over there and one here in the left corner, one in the left corner here on the button side, and another one here. So 4 screws which we have to take out. And again, you need of course a screwdriver which fits here into these screws, and then, or rather than that, it is really easy, so that is no big deal to get these screws out, and then we really have the possibility, or we are able to take our, yeah, let me call it audio board off. Yeah, you can take them out with a tweezer, because most likely you're not able to get down with your fingers. These are really little screws, but all is manageable. It is not really a big deal. And of course, before we go ahead, we have to pull these connectors here, and again, very gentle. Do not put too much force here, that you do not damage these connectors, because that is what we need afterwards. And underneath here we have of course our RF board, and therefore yeah, do it with a bit patience and very carefully, and then we will be able to really carefully lift our board here out of the housing, and here it is. So here we have our RF unit, alright, and here we have now our, so we can take this metal frame here away, as we do not need it any longer. And still we have to be careful here with our flat wire, but other than that it is out, and we really can go ahead. And when we now flip it over again, we can see here the foil side of the audio board, and you see all the chips and all the components, and you see this radio is from, I believe, the beginning of the 90s, and you see it has all done already in SMD technique, and that is really a piece of beauty. And yeah, you see, for instance, here our pots, which are from Alps, so high quality components as well. And if you see here the little speaker, for instance, it is a high quality Foster one, which is not used in consumer electronics today's. So this is really a high quality speaker which has been built in here. If you already wonder, for instance, what underneath this paper, so this is the battery for holding the memory. But first of all, let us get here some help from our microscope just to inspect here the PCB if we have any findings which are unusual, and to see if we already have really some leakages here from our electrolytic capacitors. And yeah, therefore let's take our microscope to see what we have here on our board. Okay, and let's start our inspection here. And already again we have here the spider's web again, and well, here underneath the spider's web we have some odd solder points, and I'm not sure what that means, and this is funny as well. So it looks a little bit as somebody has been in before, maybe. I'm really not sure, but yeah, you see flux residue, and this little, I believe it's a little transistor or maybe a dual diode pack, no idea. You see that yeah, it is not soldered in a professional way. Anyway, so let's go ahead here to the button end, and here we see one of our electrolytic capacitor which has to go. This one, and as well here the solder points are looking quite good, but anyways it has to go. Here another one, 33 microfarad, and our pins on the ground here on the PCB looks fine. This looks fine as well, but here, what is this here? It looks like that somebody already has soldered here at this resistor, don't know. Here another 33 microfarad capacitor, and here 4.7. and here another 33, and here we already see, yeah, that maybe already some leakage, but it can also be some flux that is not totally clear. Let's see what we see here on this side. Well, there is also some residue here down on the board. So again, it can be flux, but it can be some leakage out of this capacitor as well. So we don't know. And yeah, at this capacitor, I would say that this is already corrosion, definitely. So you see the PET has already gone here. So that is for sure not okay. So that is definitely a problem. This 1 microfarad capacitor, this side looks a bit better, but still not good. And yeah, here we have some residue on the board as well. So in any case, so what is that? So I have no good light here in between. Let's see if I can improve it a little bit, but this here does not look very good. Don't know. Anyways, that is a 22 microfarad capacitor, and I believe it does not really look very good. So we do not see any residue or leakage from these capacitors, but I'm sure that these capacitors are dried out, so we have to swap them. Just remember, these capacitors are lying here all over our RF board, and that means we really have a lot of heat all over the years, and that means these capacitors are drying out for sure, so we have to swap them. And I believe that we really can get a lot of problems out of the way if we have new electrolytic capacitors or even tantalum. I'm not quite sure what I can fit in, but yeah, that is what we have to do first. Okay, so let's see if we can get it managed. So I just want to take some ESR values. I'm already set here my LCR meter to ESR and to 100 kilohertz. Testing frequency, and yeah, our 33 microfarad capacitors, which we have here down in the circuit. Let's say they should be somewhat better than 10 ohm. So I do not have here the right figure, but you know, if we assume 10 ohm is acceptable, so let's simply test again against 10 ohm ESR, and yeah, let's see if I'm able to go down here to, you know, the to the pins, and you see already the first one is showing up 111 ohm, which is definitely too high. So let's see what this guy shows. It is, well, what is it? Really? So that is 500 ohm, so a half kilo ohm, which is definitely too high. The next one, let's see. It is 323 ohm, which is too high. And this is 270 ohm, which is definitely too high. So are you still able to see what I'm doing? Yeah. Okay, let's see what we have here. I'm doing this only to prove my assumption. So this is that true? Once again, let's see if I have a good contact here. Yeah, nah, come on, this is impossible. I'm yeah, no, it is 8.9 kilo ohm, which is, you see, I have some problems here to get a good contact, but what you can see, it is somewhere in the kilo ohms. And I mean, I think I do not really comment this test results. So all our ESR values are really showing up with much too high values here. Look at this, somewhere 3 point something, and you may understand if the capacitors are really dry, like we have it here. So this one could be okay. So this is 1.9 ohm, and as I said, I would expect them to be around, yeah, let me say 10 ohm, as I already said, and so that one looks good. But other than that, here this 447 ohm, which is definitely too high. So I mean, I know that this is a problem of this standard radios, that all the capacitors are dry, and if it is even worse, we already have the residue here on the board. So we can be lucky that we do not have residue from a leaking capacitor on the board. So remember our Kenwood TS850, how much leakage we had on the PCB, so we really can be lucky. But if we have this high ESR values, that means, on the other hand, that the capacitor do not have it capacitance any longer. So the capacitance will have dropped to a very low value, and that is the reason why you know, the circuit doesn't work any longer. I mean, I cannot test, as you know, the capacitance here in circuit, so I only can test the ESR in circuit, but not the microfarads. So therefore we use our ESR test value, because we know if the ESR is going up, then our microfarads most likely have dropped to almost zero, and then it is clear that this circuit can't work any longer. I just wanted to prove that it is true what I have said. All the capacitors are gone, so they all dry, and therefore they have to go. Okay, now where we know that all the capacitors have to go, we start preparing here our work, because of course, first of all, we have to remove all these caps here from our board, and to know exactly where we have pulled off which value, and to be sure what the orientation is. I mean, okay, we have on the board, I've seen it here and there, so let me go down there, for instance. So we have here that this is a plus side, but anyways, it is definitely not bad to exactly know what are the values, because when we have taken them off, then it sometimes is a little bit critical to exactly know what is the orientation, what was the right value, and it is easy to mix it up, and therefore it is always good to take a photo. And yeah, I have printed it out, and so I easily can see what the value is. For instance, here, this is a 33 microfarad electrolytic capacitor, and you see here this black bar, which is telling us that is minus, but on the other hand, on the board, we have our plus indication as well. So now it is prepared, so we know where the new capacitors have to go to, and now we can start here preparing our solder work. And first of all, I just wanted to take this housing here away from our board, and that is anyway necessary, because we know that we have here some problems with our push buttons, and I just wanted to clean our field here, our button field, that the dirt is out of it, and then most likely our board here will work, our push buttons will work again. So therefore I gonna take out this board as well, and then we can put here our housing aside, and then we start here preparing our processor board, or RF board, not RF, AF board, that we can start replacing our capacitors. And now be careful, we really have here a lot of very small screws which are here around of our board, and of course we have to take them out, and then additional to that we have to unsolder here our speaker, and therefore, I mean, that is not an difficult task, but anyways, always be careful that you do not destroy here anything, and then we can probably lift it out. So here we have still a little bit, the microphone is here in a little yeah, how do you call it, compartment or whatever. So that is, you have to lift up very carefully. And well, then our first inspection here might be our pad here, our keypad. So that might be first, because I just want to see if I see that here the keypad is broken, but it looks like that here our graphite or whatever is on, our keypad is still on, and I do not want to clean this side. Also, we see here, for instance, here some residue. Maybe that something was able to pass here in some liquid. But I do not really want to touch too much here our pads, because it is easily to destroy here our conductive surface. So don't touch it, leave it alone. Most likely it is just fine, and from the first inspection I would say it is fine. So the only thing we have to do is to clean here our contacts here on the board. So in most cases that will be fine, and afterwards our keypad function is given. So therefore that is definitely here our first what we do. And if for any reason the keypad doesn't function afterwards still, then of course we have to go into troubleshooting. But now I go ahead with preparing here our board for removing our capacitors. Okay, and the next step was to cover here our connectors with tape to be able to protect them against the heat, because even here with my micro pencil, and yeah, you may get here an impression how tiny this pencil is. Even with this pencil it is very hard to get here. Let me do it here a bit better here. So, and you see, even with this pencil, it is really hard to get down here to the solder points. And before we start removing the electrolytics, we go and put a bit new solder here onto the pads to make it easier to get them off. And therefore it is really a challenge to not destroy or even hurt here our connectors. And I mean, even here with our tape, you may only touch it for a little moment until it will do any damage to them, even with our tape. So we really have to work very carefully. And yeah, therefore that was the first step. And as I said, the second step is that I will add here some new solder to the solder points, and then we start and remove them. And yeah, we all know that there are a lot of different ways to get them off. Some simply just cut them off. I don't think that is the best idea, because always when you use a cutter and try cutting them off, you put a lot of mechanical stress here to our pads, and I really do not want to lose too many. I mean, we have to expect that we lose pads, even if we are totally carefully, but you have to expect that it can go wrong. And then there is another method that you take a player here and then grab it and then just turn them, and then they come off. So that is of course another method, but you know, you can easily rip off the pads as well. So even we do not really know how good this board is, this PCB material. So I'm not really convinced that that is here the best idea. So what I gonna do, or I gonna try, is, as I said, I just fill here all the points with new fresh solder, and then I try to get it off here with our hot tweezers. And of course there are some locations where it is really hard to get down, and that we have to see individually. But anyways, what we know is we really have to be very, very careful. Okay, so all the old capacitors are out, and I can tell you that was really in the right moment. So of course it is not cleaned, and I left it as it was. I just cleared up here with a solder iron a little bit here our solder points, of course, but you see that under this capacitor we already have corrosion, and here as well, and here we have the same situation. So there was corrosion on the board. So now come on, focus. So I really can tell you it was in the last moment that we have taken here these capacitors out, and now the next step is of course cleaning the pads, and then before we go ahead and take here our through hole components out, we will have a board inspection what are the pads are, if they are still good. But anyway, so next step is I clean now with solder wick here my pads, and yeah, then let's see how that comes out. Okay, so here is our board on the microscope, and you see we were lucky enough to not lose a pad. So I've already cleaned it, let me call it pre-cleaned it with alcohol, as you see. And yeah, the good news is that we have not lost here really a pad, so everything looks really pretty nice. So this one here is the most nasty cap, because you see we have here already leakage on the board, so we definitely have to get it off here. We can't leave it here on the board, otherwise it will eating the copper away. So we already know this story. But yeah, as I said, we really are early enough, and therefore lucky enough that we do not have completely leakage here on our PCB. So that makes me a kind of glad, because now it is definitely much easier to go ahead. So of course I will clean this here off, and we already know we only can do it if we scratch it away, because there is no other way to get it off here from our board. But we have to do it, because we really do not want to jeopardize here our board. And you may see, and that is something I definitely have to double check, there we have a via, and maybe the via is already jeopardized, so we need to check that very correctly. And then the next step, of course, will be to take off here our through hole capacitors. So this 3, of course, and this one here, and then we will give a final clean to the board, and yeah, then we already can start and replacing new capacitors then. Alright, status so far, you can see I have cleaned off the board here, so all the acid is gone, and that means we can replace our capacitors down there. Then I have already taken out here our PTT switch, which is worn out, and I have already here the new PTT switch which will get here into this, and I have taken out here this super miniature electrolytic cap, and yeah, this is another proof that we have really high quality parts. As I already said, here we have Nichicon capacitors, and believe it or not, I've tested all the values. So the capacity, the ESR, the tangents, delta, so all values I've tested, and this capacitor is like new. And there you definitely see the difference if a manufacturer puts in high quality parts, or if there is some crap built in. So that is the difference. We still can use these capacitors. Okay, and how do we go ahead? I mean, you have seen that we have down here all the little aluminium electrolytic capacitors, but you have also seen that the situation down here is not so easy for soldering, and therefore I have decided to put down here in these difficult locations, I put down titanium capacitors, because as you see they fit in here much better. So for instance, this here is 33 microfarad type, and it is 16 volt type, and therefore it fits in without any problems. And to know where we have what, we have now here our nice printout where we easily see. So if I take it here like this, and you see that in the location here down, right, it's a little bit critical, I know, sorry for that, but this is a location here, and you see how critical it was, and I simply want to make it a bit easier, and therefore we use these capacitors here, and that is much easier to solder them back in. And wherever we have a problem with space, we use these capacitors. But for instance, here on this location here, it is very, very easy to use a new, nice Panasonic electrolytic capacitor, SMD electrolytic capacitor. And with this capacitor, it is not it is very easy to put it down here, so therefore I will use these capacitors in locations where it is easy to handle. Okay, so let me simply solder down all the new capacitors here in its location, and then we go ahead. Oh, and one very important step I have almost forgotten. So we need to check for continuity. So this, let me see that we can get it here a little bit better here into our field of view. So you remember down here we have this vias, and we really need to check if we have continuity, and therefore I hope I can handle it here. Let me see. And we need to check if it is working here. So let me see. That is a funny situation. Me behind the camera, and I do not see where we need to test right now. No, I really can't see it here. That is funny enough. Sorry, I have to do it off camera, but I hope you get the idea. So we have several vias here, and so for instance down here, all right, so we have to test all these vias, because it might happen that one via is gone, and then we would have a very hard time with troubleshooting. So if you have taken off all the capacitors like we have done it here so far, then it is very important that you check here all the vias, because here on the other side of the board, so this guy here for instance is our audio chip, and well, all the capacitors are here connected to this audio chip, and if there is a via which is gone, then we definitely do not have any audio. Okay, and that is now the situation here on the board. So all the new electrolytic capacitors, or tantalum, whatever you like, capacitors are in, and the new PTT switch is in as well. And yeah, more or less I was already able to clean the board, and yeah, as discussed before, wherever it was a little bit critical here with the space, I used the tantalum type. So you see how close this solder joints are here to this plastic connector, and you know that is always critical, or here where it is very close here to all little pots. So therefore that are the spaces I have used the tantalum capacitors, but other than that I was using here the normal capacitors. So nice Panasonic types. So that is it so far. As I said, everything is prepared so far. I have tested all the vias, of course, before, so vias are okay as well. And as discussed, I have cleaned here these contacts on the PCB for our keypad with alcohol, because we had no function of our keypad. So let's see if the cleaning has solved the issue. And now we are yeah, we are ready to put it back here in our housing for a first test, because we need all the connections back here to our RF unit, and then we can do a first test. And yeah, if something doesn't work of course, then we have to go and do some troubleshooting. Very important when you all put it back together. So you have to clean up here the old heatsink and the heatsink. I mean, especially the grease here. So you have to clean off the old grease here from the heatsink, and you have to apply new, because it is here for this power components. So that is very important, so don't forget it. Right, so the radio is here in test configuration on the bench. So that is that I still have access here to our circuit, but all parts are wired together, and our power supply is connected to the radio. So let's see if we have function back again. I mean, remember when we did our first test, we almost did not have any audio, so it was very, very weak or completely gone, and we had no keypad function. So let's see if that is back working. So let me switch it on here, and yeah, radio is firing up, which is very nice. So let's see what is going on here with our audio. Ah, so that is very nice. So you hear, obviously, our audio is back, so very nice. So let's see what's going on here with our keypad. Let's see. And yeah, obviously that is working as well. So you see, I can easily change here my settings. So that means, let me see if the light is working as well. Yeah, and I hope you can see it. So light is working as well. So that means that the function of our keypad is back. Our audio is obviously back. So let's see how we can proceed. Okay, so signal generator is now connected here to our radio. And let's start with 23 centimeter. So we have dialed in 1.297 gigahertz, and let me switch on the signal generator. Let's see. Okay, so we have signal, which is nice, and come on, here we are. So working just fine. Okay, so let me turn it down and let me dial in 435. So 435.1 megahertz, and wonderful, wonderful. Here we are. Very nice. So that definitely shows that the radio is working. Let me simply let me switch off here our signal generator. So I will now put the radio back together, and then we can do our final tests and our final work, which still needs to be done. Okay, as we already said, another problem here with this radio is that the knobs are getting very sticky and crusty, and to solve it, we simply take isopropanol alcohol, and we simply drop here our knobs here into the isopropanol and give them a couple of minutes here in the isopropanol, and then everything should be back very nice. And yeah, let's see, now we let them rest here, as I said, for approximately 5 minutes or so, and then let's check them again if we can use them, and if they are then not that much sticky as they are in the moment. Right, after approximately 5 minutes, so let's take out here one of the knobs, and you see these knobs are really gray. And if I now put it here into piece of paper, you see that I can clean off here all this sticky overlay, and finally our knobs are really getting back black, right? Because you see all this layer which was here on our knobs are really cleaning off, which is very nice. And finally we will have our nice black knobs back, and looks like new finally. Okay, so I have to clean all of the knobs in the same way, and then you can see the final results when I have put them back on the radio. Alright, and our radio is back together, and you see how nice the knobs get after the cleaning, so very nice, like new. And radio is really working fine. I've tested it for sensitivity, I've tested the transmitter, and of course the receiver on both bands, UHF and SHF, and you really hear our volume level is back, so everything is done. Our functionality on the keypad is back, so really just fine. Glad that we get this old radio really back working. And really, what can I say? It is still a great radio with an excellent performance, and therefore it is really worth to restore this nice standard. Okay, but that's it for today. Thank you for watching. I hope you enjoyed it a little bit, and if you like it, please give me a big thumb up for this video, and catch you next time. Bye!